All right, so when you're given a picture like this and it says graph, okay, and we're going to look at some more that are a little more complicated than this, although this one's pretty complicated. But the first thing you got to kind of identify is, kind of what does the basic picture look like? Which of those graphs that we talked about models this equation that you see? And the answer is this equation is kind of modeled by y equals x squared. That's kind of, we call that the parent function. Okay, so you'll hear math teachers refer to things like parent function, which simply means what picture am I dealing with? Okay, and if you don't know the pictures, what I end up with a lot of students is they go like this. Well, it's something that's been moved. Thank you. Thank you. It's something that's been moved. Yeah, I think it goes up 5. Okay, well, what is it? That thing you're supposed to move. What does the x squared graph look like? It looks like a parabola. It's concave up. It's this picture here. It's this U-type shape, right? I call it U-ish. Which way has that been shifted? Very back. I don't know your name. Say it for me. Okay. Go ahead. I don't want to put him on YouTube like that. Which way does it shift? The x minus 4. What's this going to do to the graph? It's going to move this u. See, watch this. This is how good I am. Watch this. Bam. It's going to take that u. Bam. It's like John Madden right there. Bam. And it's going to shift it which way? To the right. The minus 4 is going to shift it to the right 4. And then do what? Up 5. This will shift it to the right 4. The plus 5 will shift it up 5. So that ultimately this piece just takes over 4, up 5, and it looks like that. What's up? See, in the hands of a lesser professor, that would have been a problem. And now we just label those as 4, 5, just like that. See, clearly it is. 1, 2, 3, 4. 1, 2, 3, 4, 5. You see? Perfect. Okay. Any questions on that? Now, let's try another one. Let's go. This problem brought to you by Burger King. Have it your way. X plus 2 cubed, x plus 2 cubed minus 6. Okay, what would that look like? What would that look like? Which one is it? Yes, it is that one. It's the snake. Got it. Mm-hmm. Probably should have paused it while y'all worked on it. Can't see what?
You said what?
I said I probably should have paused this while you worked on it. Here. All right, which we can confirm that the x cubed graph looks like this, right? That's the x cubed graph. So now we got to take that. I don't know how I did that last time, but you know what? Who cares? And which way is it going to shift? This is going to go left 2, down 6. 1, 2, 1, 2, 3, 4, 5, 6. Now, for 857,468 points.
Will it be in the next test?
On test number 8. On test 8. What is the Y-intercept? Do. It's not -6 because -6 is over here and it's not touching the y-axis. I want to know, where does it touch the y-axis? Maybe 857,468 points is not enough.
Put it on test 2 and we'll get it.
0.23. I'll sweeten the deal.
Is it 6?
It is not 6. Where does it cross the y-axis?
Would you subtract that?
2 zeros.
Say it again.
2
2
0.
0. 0 2. The y-axis, not the x-axis. 0 2. Playboy says, for those of you watching at home, that's the dude's name. Don't get mad at me. If you're going to call Lakeland, but his name is Playboy. What is it on Snapchat? Playboys R Us or something or other? Oh, yeah, okay. I ain't put that out there for him, though. Oh, Jesus. The idea is to cross it at 2, and I just crossed it at -1, but you get the idea. Watch this. Bam. Make the dot bigger. All right. How did you get that? I mean, that 0 2 sounds really good. Is it just this number right here? It is? Then a miracle occurred. How do you get 2? The answer is 2. How do you get it?
So if you can pop points using like the -1, 0, 1, 2, and then you cube them, and then so wherever it whenever it goes back to 2, positive 2, so it moves right 2, so it goes up 8, so that's where it would cross the y-axis.
The way you find the y-intercept, you plug in x is 2, which is essentially what he's saying. For the rest of your life, whether that's days, which I hope it's not, whether that's years, which I hope it's not, I hope it's many, many years, but for the rest of your life, when your grandkids come to you 20 years down the road, or 30 years down the road, or 40 years down the road, and they say to you, Grandma, Grandpa, Poppy, whatever the hell your name is, how do you find the y-intercept? You tell them plug in x is 0. I've been doing math for, about 8 minutes now, and it's been the same for the whole 8 minutes. It's never changed. Okay? You plug in x is 0, you get 8 minus 6 is 2, and that is your y-intercept. Okay? You need to know the y-intercept. Why? Because here's what happens. I give you y equals absolute value x minus 5 plus 2. Okay? I say graph that. And this is what I get. Because I'm going to give it to you. I'm going to give it to you. I'm going to give you this. Nothing. I'm going to give you this. Okay? I'm going to give you that. So on the test, you're going to have a problem. You're going to have a grid underneath it. I'm going to say graph it. And this is what I get. I get people who know a lot. Okay? Who know a lot. They know that the absolute value is a V. Thank you, Wink. They know that. They know that it shifts to the right 5 and up 2. They've got that part figured out. And then what I get is some, Lord forgive me, some half-ass graph that looks like this. What?
So it's like gonna be
Looks like our old bird.
except for like the last one.
Or I get this, somebody who like puts the graph on a diet. And then I go like this. What are you doing? I graphed it. It's a V. It shifted to the right 5. It shifted up 2. Or I get somebody who's like, it's a V. Shifted to the right. Does everybody see what I'm saying? There are a whole lot of V's that can be graphed. I need the right one. How do you find the right one? Try not to break the pencil. How do you find the right one? You plug in x is 0. The absolute value of negative 5 is, plus 2 is, there's 6, there's 7. Now you have the right V. Does that make sense? Now you have the right V. Okay. Does everybody see what I'm saying? Because I don't want to mark, because what's going to happen is you're going to draw, if you draw it wrong and you don't get the Y-intercept correct, what I'm going to do is -3. So I'll give you some credit, but not enough to pass the class. Kind of like when you go to that party and they got pretzels. Well, they got some food, just not enough to eat with.
I have a question.
Yeah.
The problem before that, I think it was like x something cubed, put it that way there.
Yeah, yeah.
Plus 2 cubed.
Yeah.
So instead, you just take the x, put the 0 in, right?
Yep, plugged in x is 0.
So you put that, so that would be
2
2.
cubed.
Right?
Huh?
So you would cube the 2?
Yes.
Okay.
Which is 2 times 2 times 2, which is 8.
Okay.
Yeah, we good? Everybody good? At this point, what I'd like for you to do, because let's just talk this last one through. Y equals square root x plus 4 plus 5. Let's talk through what you need to see, and we're running out of time. We'll go straight to the big finish. Okay, we're running out of time. We go straight to the big finish. Here we go. What does the square root graph look like? It's the upside down Nike, right? So which way is that going to shift? To the left, 4, and then what? So left 4, up 5. So we're here with our symbol, yes? Where does it cross the y-axis? At 7. Who said 7? Roy. Okay, how'd you get 7? You plug in 0 for x. 0 plus 4, taking the square root of that, plus 5. 2 plus 5 is 7. So you plot 7, and now you draw that graph. Okay? I'm not terribly worried about whether or not your graph is perfectly symmetric and all that stuff. What I am worried about is um,
They're all close.
they're all closed circles, yes. So just out of curiosity, what's the domain and range here?
Domain is -4.
Domain is -4 to infinity. What's the range?
It's 5.
Range is 5 to infinity. Those are both brackets. Okay. All right. Good job. Good job, Roy. Good job, Schneider. Good job, everybody else who answered. Hey, last thing before I let you leave. And then again, 1:15, we're going to, in 5 minutes, we're going to be next door with SOS. Want to speak to you specifically, and you asked me earlier, and I kind of forgot, but I remember now. When I talk about symmetry, there are 3 types of symmetry. There's the y-axis, which looks like this. That means if you fold the graph across the y-axis, that it mirrors the other side. There's the x-axis, which looks like this, which means if you fold it across the x-axis, it mirrors on the other side. And then there's the origin, which looks like this. Well, I didn't do a good job getting through the origin, but that's the origin, because if you flip it across the y-axis, or the x-axis first, and then from there, flip it across it's 2 flips. It's the x-axis, and then the y-axis, then it will mirror. Okay? So we call this odd, we call this even, and we call this x-axis. Okay? There's no name for that because it's not a function. Okay? All right, we're out of time. We'll try to do better next time. Until then, take care of yourself and each other.